Hi everybody, and thanks for joining us today on day 2 of Innovator Island, where we're building a serverless web application for a theme park. Everything today is recorded, and you'll receive links tomorrow for today's session and at the end of the week for all 5 sessions that we're covering. So for anyone who wasn't here yesterday, my name is James Bezic. I'm a developer advocate for the AWS Serverless team. I'm a self-confessed serverless geek. I've been building serverless applications for a couple of years now. And before this, I was a product manager for quite a long time, as well as a software developer for quite a few years. Prior to AWS, I worked in a number of different startups, but also large companies such as USAA and Rackspace. And I have many interests, including theme parks, which is why I built this workshop. On this screen, you'll see my email address and my Twitter handle. So during the course of these sessions, if you have any questions after we're finished, feel free to reach out to me and I'll try my best to help. So here's the agenda for today. Today is day 2, though it's always day 1 at Amazon. Yesterday, we set up Cloud9, and then we deployed the backend application and the front-end application with Amplify Console, and you ended up with a public URL for a skeleton version of the front-end application. Today, we'll be expanding on this and making it a real-time application that takes real-time messages from the backend. Now, the purpose of these 5 days is really to teach you to learn to use a range of different AWS services to learn to build real-time web applications. All of the code is provided for you, so you don't need to write any actual code to solve any of the problems. We have serverless experts and other developer advocates on the Q&A ready to take your questions. So if you have any questions today, it's a good time to ask because we're all here. And this session is live, so anything you ask during the breaks, I'll also attempt to answer some of those questions. So today's topic is about real-time messaging. So you probably use websites all day long that use these patterns that we'll be talking about today. So these are apps like email applications where you have the app loaded, and instead of you having to refresh, it tells you when new messages are waiting. In the theme park application itself, we have a ride system that we want to connect to that publishes wait times for the rides into the front-end application. And the front-end application is expected to have 50,000 visitors, so we're going to be using tools that enable us to scale up to this size of audience. So some of the tools and services we'll be discussing today include WebSockets and also the publish-subscribe pattern that's used to connect this all together. This varies from the query response pattern that you may be used to if you use services like API Gateway. We'll also be talking about the MQTT protocol and a little bit about SNS, the simple notification service, and how we can integrate that into this pattern. Now, in web applications wanting to retrieve real-time information, we're going to be using AWS IoT Core to make this happen. This is a service that can help you implement PubSub in a serverless way, so there's nothing for you to manage on an infrastructure level. And this is a really good pattern to fit into sparse-style applications, which are single-page applications like React, Vue, and Angular. Now, most of today will be going through the walkthrough of the workshop and the coding. Now, today I recommend you follow along what I'm showing on the screen and following through the module later after the video. And the reason for that is I want to talk about many of the concepts involved, and so it's easier to do this if you follow along. But later on, if you decide to follow the module after the session, you hit any problems at all, just email me or hit me up on Twitter. I'm happy to answer those questions too. So on the left-hand side of your screen, you'll see a Q&A pod, so please put any of your questions there, and moderators will address these as they come in. At the conclusion of today's presentation, there'll be several poll questions provided during the Q&A. Please provide us there with any feedback you have about how the session went for you, and any ideas you have about what went well, what you think could be better. So before we get started, just a few prerequisites and housekeeping that are worth mentioning. The first is that you need an AWS account to be able to go through this workshop. Now, if you don't have one, just sign in to aws.amazon.com and create an account. It's best to have a personal account with full administrator access because we use lots of different services, and if you're using a corporate account, it may be locked down in some way. Also, please use one of the supported regions. Currently, this is supported in 5 regions listed just on the screen here. It's also shown in the GitHub repo on the main page. These regions have all the services available that we use for the workshop. Once you've selected a region, please don't change it over the course of the 5 days because we'll be using the infrastructure that's in that region. Now, in terms of cost, everything in this workshop, in terms of attending it, is free. We're providing this free of charge, and most of the steps we provide in the GitHub repo should be possible to do within the free tier. So if you have an account that's brand new and it has 12 months to go, that has a lot of different free tier allowances that cover most of the things. You can see what's covered in the free tier allowance by looking up on AWS documentation. Now, to take part in today's activities, you'll need a laptop or a desktop computer, not a tablet. So if you only have a tablet, I'd suggest just watching the video today and then following through with the exercises once you have access to a laptop or a desktop. Also, please use Chrome or Firefox browsers for optimal compatibility today. We're going to be using the Cloud9 IDE, and we found it works best with those two browsers. We'll be building a serverless application using a range of different AWS services, so having some familiarity with the AWS Management Console is really helpful, but it's not essential. Everything we're doing here continues from day one, so our goal is to help make sure you get through the workshop, so don't hesitate to answer any questions at all as they come up. So a major part of the application is showing guests how long the wait times are on the rides throughout the park. So within the park, we have a system called the Flow and Traffic Controller, and that monitors how many people are in the lines for various rides. This is a separate system to what we're building today. But what we want to do is connect to this system today and set up the back end so we can publish live wait times through to the front end application. So the code repo and instructions you need to be able to follow this are shown on the screen at this bit.ly link. We'll post this in the Q&A as well so that you'll be able to access this at any time. But anytime you need to get to the GitHub repo, it's just bit.ly/innovator island. So here's an architecture of what we're building today. The grayed out areas are what we'll be doing tomorrow, but the main part today is the bit that's lit up in the diagram. So you'll be creating a Lambda function that's invoked by the SNS topic that's owned by the Flow and Traffic Controller. So as messages come into this Flow and Traffic Controller, they're published to SNS, and we're going to set this up so that invokes this real-time publisher Lambda function. This Lambda function will then publish the latest messages to a DynamoDB configuration table, and will also publish the messages to a Park Alerts IoT topic. Now the front end then listens to this IoT topic via a WebSocket so that the ride times will be shown on the map within the front end in real time. So after this section, you'll have a real-time front end application. Okay, so let's get started. So go to this URL now, bit.ly/innovator island. I'm going to close this deck and then navigate to my desktop so you can see me follow through the steps. So the first thing I'm going to do is go to that bit.ly link. So bit.ly/innovator island. And these are all the instructions for everything we'll be doing over the next 5 days. So yesterday we set up modules 0 and 1, the setup and deployment. If you've not done these yet, don't worry, you can just follow through these in your own time. Today we're only going to be doing module 2 real time. So I'm going to click into there, and these are all the instructions I'll be following through in this session. So let's talk about this just in a little bit more detail before we start. So the Flow and Traffic Controller, this system that measures ride time, wait times, is publishing once a minute to an SNS topic that we have access to. So the first thing we're going to do is create this Lambda function that's going to be listening to this SNS topic, and then it's going to be pushing those messages to a DynamoDB table and an IoT topic. So if we scroll down, this is where we start with the work today. So the first thing I need to do is make sure I'm logged into my AWS account, which I am over here. And from here, I want to log into my Cloud9 IDE. So from the services dropdown, I can search for Cloud9 and click this. This gives me a list of all the environments that I had open, and this is the environment I had from yesterday. So all I have to do is click on Open IDE, and this will start this environment again. If you've not started it since yesterday, it will take about 30 seconds to a minute to start up. I started mine earlier, so it's immediately available. You can see all of the files we downloaded yesterday are still there, and the terminal window is in the same state as it was yesterday. The only thing that's different when you use Cloud9 between multiple days like this is that the terminal doesn't persist environment variables, so we're going to restart some of those today. So back in the instructions, the very first thing I want to do is just start some of those environment variables or store those environment variables again. So I'm going to copy these three commands, which persist the region, account ID, and deployment bucket name into my IDE. So I'll just paste those in there. And if I echo back any of these, like the account number, you can see all these are just temporary environment variables to make it easier for other steps that we're following throughout the workshop. So down in step-by-step instructions, the next thing we want to do is go to the management console and then go to the Lambda service, and then making sure that our region's the same as the one we had yesterday, we're going to create a new function. So from here, I'll go to the services dropdown and go to Lambda. I'm going to hit create function in the top right-hand side there, and then I'll go back to the instructions. So we want to create a function called theme park ride times, and we're going to use a Node.js 12x runtime. And then these are the parameters we want to follow in the configuration. We want to set this up to use our theme park Lambda role in IAM, and when we've put all these in, we're going to create the function. So I'll go back to Lambda. I'll paste in this function name. My runtime is by default is Node.js 12. Then under permissions, I'm going to use an existing role, and I'll select the role called theme park Lambda role. This is a special role that was configured as part of the deployment yesterday, so it has all the permissions that we need, so we don't need to do anything to make this function work properly. Next, I'll hit create function. Great, so this is our brand new Lambda function. So back in the instructions, you'll see those are the parameters that we entered for this function. And now we're on step 3. So we want to add a trigger to this Lambda function so it has an invoke source, something that causes it to run. The first thing we're going to do is set up this SNS topic to be that invoke source. So we'll click on the add trigger button and then follow these instructions to set this to this ride times controller SNS topic. So I'll click on add trigger, then in the drop down I'll choose SNS as the service. Now under SNS topic you'll see a couple of topics. One is used by Amplify and the other one is the ride times controller. So let's select this second topic, and by default we'll enable the topic straight away, and I'll click on add. So back in the Lambda console you can see now that this has been set up to trigger the Lambda function. Okay, so we're at step 5 now in these instructions. So we want to open up this Lambda icon at the top just to show the code display. And that opens the function card below. So I'll just show you that right now. Because the SNS topic is displayed, it shows this, but if we click on this button here, it opens up the code display in the same window. So we're going to fetch some code from our Cloud9 IDE and paste this into the Lambda function. The code is located in this area, the number 2 real-time directory, and it's called app.js. So I'm going to navigate to that directory in my Cloud9 instance. So under real-time, I'm opening app.js. Now this code here, I'm going to go through in some detail with you once we've deployed it, but for now let's just cut and paste this code, and I'll paste it directly into the Lambda function. So first I'll remove all this code here, and then paste in what we've just copied off the clipboard, and then click on the save button. So back on the instructions, what we're going to do now is step 7. So we've pasted the file contents into there, overriding this, and on step 8 we clicked save. So we've done those two things. So the next step to this is to add environment variables to the function, and there are 3 environment variables that the code uses. The first is the IoT data endpoint. This is the host name of the IoT service that it needs to know. The second is the IoT topic, which is a static topic called theme park rides. And the third is the DynamoDB table name. So I'm going to add each of these environment variables, and then using the instructions below, this shows me how I get the values for those environment variables. So first of all, I'll go back to the Lambda function and scroll down to environment variables. It's important here to make sure you select environment variables and not tag. It's very easy to pick the wrong section here. So just make sure that you're on environment variables and click on manage environment variables. Now I have 3 variable names I'm going to copy across. So I'll add 3 times just to create 3 boxes. And I'll copy across these from the instructions. IoT data endpoint. The next one is IoT topic. And then DynamoDB table name. So now let's figure out how we get those values. In the instructions, the first value, IoT data endpoint, I need to get this from the Cloud9 IDE by using this CLI command. So I'll copy this. And in my IDE, if I paste that command, this tells me the endpoint address for my account. This will be different in your account. So I'll copy that value, go back to the Lambda function, and just paste. Oh, I didn't copy properly. I'll just copy this value there and paste that in. You should find the format looks very similar to this address in your case. IoT topic is a static value, so we're going to set that to theme park rides, this value up here. I'll paste that in. And now we just need the DynamoDB table name, which is in step 3. So I'll take this command and paste that in. Now what this command does, it really just uses the CLI to query DynamoDB to give us a list of tables. And we're just using grep to return that one table that we need. You could get this same information through the console. There's nothing special about the way I'm doing it. It's just a bit easier for the workshop. So I'm going to take the name of the table that was created as part of our deployment yesterday, and I'll just copy that and now paste this into the Lambda function. And then I'll save these environment variables. Now those have been saved. When I scroll back down, you'll see these are showing up in this environment variables panel. Great, so back in the instructions, we've now reached the end of step 5, where we added each of those environment variables, and I hit save. So we've got to the point where this Lambda function is now being invoked by the SNS topic and will be publishing to DynamoDB and to this IoT topic. Now before I continue with the instructions, I want to show you a bit more detail about how this really works. So within the Lambda function itself, for the last couple of minutes while we've been talking, it's already been invoked several times because the SNS topic is continuously receiving data once a minute. I can see this if I look at the monitoring tab and then go to the view logs in CloudWatch tab. So every time this Lambda function is being invoked, it's logging out what's happening. So if I take the most recent log file, which is the one at 1220, and I click that log stream, I can open up and see what's happening. And you can see it's been called 3 times since we've been talking, and it shows that it's been invoked by SNS. And if I open this, that's the message, and it just confirms that this has been saved to DynamoDB and also published to IoT. Now we can prove this to ourselves by looking in the DynamoDB table, so I'm going to show you that quickly as well. I'll go to the services drop-down. open DynamoDB. Now in my list of DynamoDB tables, this is my theme park backend table that was created by the stack that we deployed yesterday. And inside items, I can see there's a new item called config wait times. And this is being populated by that Lambda function. So this wasn't here before we created that Lambda function. So we know the Lambda function is working and it's populating this data into the DynamoDB table. It's also publishing to the IoT topic. But next what I'm going to do is I'm going to connect that to the front end so you can see the information flowing through into the front end. And then I'll talk a bit more about how this IoT topic works. So back to the instructions where we got to. In module 2, we're now at the updating the front end section. So the front end we published already to Amplify. Let me show you where that is in terms of where we left it yesterday. So if we go to the Amplify console, which you can go to by going to the services menu and just typing Amplify and opening the link. In Amplify console from yesterday, we published a version of our front end. And we can click this to open this up. This is the version we published yesterday, and I'll just open this in a new URL. So you can see this is where we got to. So this is the front end that we published. Now at the moment what it's doing is it's getting that the list of times from the DynamoDB connection that we created earlier, but it's not actually yet receiving over IoT. So those times won't change right now. So I'll just close this, then we'll continue with the instructions and then republish the front end, and you'll see then it has real-time list of times coming in to the front end. Okay, so back to updating the front end. Let's go to the step-by-step instructions. So from the Cloud9 IDE, first we need a couple of different parameters. We need to know the identity pool ID. So we're going to get this value. Go back to Cloud9. I'll just clear this. I have two identity pools because I've got a couple of different applications, but the one you're looking for is the one beginning with theme park identity pool, which is this value here. Next, we want to know the host name, so we run this command. I'll paste that into Cloud9. That is the IoT host name, so we need that again for the front end. And finally, we want to know the region that we're in. This is the environment variable that we set up earlier, so I'm just going to echo that out. I'm in US East 1, you might be in a different region. So what we want to do is update the front end. Now, just like yesterday, this is in the theme park front end directory in the source directory. There's a file called config.js that contains everything you need to change for the workshop. So let's go and find that file. So this is the theme park front end directory. There's the source directory. And I'm just opening config.js. So yesterday we did module 1 and we entered this value. Today we're doing module 2. So these are the three values that we need to update. So the pool ID was this first ID that we retrieved there. So I'm going to paste that in. That's just there. The host name is this value here. And the region is US East 1. And what I'm going to do is I'm just going to stop here for a moment and let you know and just check for any questions and see where everybody is. So we'll continue with the instructions in just a moment. So we've got some good questions here. So let's talk about the SNS part of this process. So yesterday, when you deployed the application, there's actually a second application in the background, this flow and traffic controller. And what it's doing is it's once a minute publishing ride times to this SNS topic. So that's how the SNS topic is getting information. So from the point of view of our workshop, that's basically a separate system that we want to connect to in order to get information into our application. Now, a little bit later, we'll be talking about Cognito and how that fits into this whole thing, and also how the IoT piece works. But just for now, I want to show you how the application works from the front-end point of view, and then we'll go into more details. Somebody also has noticed I've posted the region in the wrong variable. That's a good catch. Let me just take that out, and I'll put that in there. US East 1. Thank you for that. That's great. Okay, so I'll continue right now. We're going to go into a lot more detail about this, so don't worry too much about exactly how Cognito fits into this. We'll be talking about that soon. So we've got these changes it made into our config.js file. Remember, in Cloud9, when you get a little circle like this in your file, that means that you haven't saved the changes. So I'll just save this file now. Once it's saved, this goes away. And I want to publish these changes to the front end, so I need to commit them to code commit. So back in the instructions, I'm going to scroll down. We've made these changes to config.js just there in step 6. And we've added these values in step 7. Now we're on the section to publish to code commit and deploy to Amplify. So I'm going to follow step 1. I'll switch my directory to the front end directory. Next thing I'm going to do is commit the changes to code commit. And you'll see there's one file changed. That's just the config.js file that we've changed there. And finally, we're going to push this to code commit. So I'll do git push. Okay, so now we've pushed those changes. Now back in Amplify console, what you'll see is that this has started another build process. So remember from yesterday, Amplify console detects when there are changes to the repo that it's been connected to, and it automatically starts that build process. So just by pushing the changes to code commit, I don't need to do anything to make those changes go live. So let's just wait a couple of minutes for these changes to take effect. I'll look at some questions, then once this is ready, I'll show you how that's affected the front end. One of the questions is there an overall architecture graphic for this system? Yes, there is. So in the GitHub repo, on the main front page, you'll see a big graphic that shows you all the different services and how they connect together for modules 0 through 3 and 4. Is there a diagram that shows how Cognito fits into the picture? At the end of this, I'm going through another deck that will show some of the Cognito pieces here, but the interesting part of this is Cognito is a very powerful system. So it enables us to do a couple of things. We can actually authenticate some messages for authenticated users, or we can pass messages for unauthenticated users. So I'll show you the parts of the SAM template that allow you to do that just a little bit later. Okay, can I explain how data flows from the SNS to the DynamoDB table, the SNS topic? Yeah, absolutely. So let me show you that code that we copied across to the Lambda function. So I'll go back to my app.js folder. Remember, this is the code that we copied across and pasted into Lambda. So what is this doing? Well, basically, this code is invoked when the SNS topic receives a new message. And that message is passed along in this event handler just here. So this code, it extracts that message from the event and it logs it out into CloudWatch logs using this logger line here. Now, it then uses two functions, save to DynamoDB and IoT publish. I'll look at the first one, save to DynamoDB. Save to DynamoDB takes that message and it constructs a params object, which basically is just the table name and a few attributes about what is in the data. The partition key is config, the sort key is wait times, and then it stores the message. And then it simply writes that message directly into DynamoDB and it saves that message. Now the IoT publish process does the same sort of thing. So further up, you'll see here, it receives a topic name and a message, and it uses the IoT Data SDK to publish that directly to the IoT Core service. So the payload is the message itself. So this one Lambda function simply gets invoked by SNS and takes that payload and saves it to both DynamoDB and the IoT service. It does this about once a minute. Okay, so in Amplify Console, it started the provisioning process, and we're now in the build part of the process where it's starting to build out the Vue.js application. So this should be done shortly. So one of the questions about authentication, how is the user authenticated in this park? So in this application, we don't use authentication to authenticate users to keep it more simple. We use unauthenticated users. But it's very easy to take what's here and add a layer of authentication, either using Cognito or using Auth0, or you could use Amplify CLI. And all you would have to change is the permissioning for the IoT topic, so you switch from unauthenticated users to authenticated users. So which part of the SAM template creates the Lambda function? So yesterday, during those deployments, we had several deployments yesterday, and that deployed a number of the different Lambda functions that were needed in the backend to get things working. Today, we created our first Lambda function together, where this was the Lambda function that consumes from the SNS topic and publishes those ride times to the IoT Core service and the DynamoDB table. One question about the SNS interval. Can you change the SNS interval instead of once a minute to once a second? Yes, so basically the SNS can receive messages anytime you'd like, and Lambda will be invoked whenever those messages are received by SNS. So the once a minute interval I'm currently using is just the way that my simulator has been set up that simulates the ride times. But you can absolutely choose different intervals for your own applications. How is IoT different from the WebSocket? Well, that's a good question, and actually I'm getting onto that once we finish this deployment. I'll show you some of that in my deck, because there's 5 different ways to get messages from the front end to the back end, and I'll cover all of those once we get to that part. Okay, so we've got our 4 check marks, which means that Amplify Console has now successfully deployed these changes to our application. So let's open up the link and see what has changed. Now I'll open up this link and press F12 to bring up the console view in the park. One of the questions that came up yesterday is sometimes browsers will cache the last version of the application. So if you find that's the case, do a hard refresh in your browser, Control F5, and that'll force loading the latest version of the application. So looking at this, I can now see this is running the real-time messaging part of the application. So what's happened here? Well, you can see that this MQTT client is now connected, and that's the component that we use to do the connection. And I'll show you that in just a second. And now once a minute, if we look at the logs, we will see a message coming through from the IoT Core service every time the rides change. So right now, this first list of ride times comes from DynamoDB. It fetches that the very first time when the application is first started up, and it maintains a connection to the IoT topic. So as new ride times come in, we'll see those logged out in the console about once a minute. Let me show you the front end part of this and how the MQTT client works, because this is something you can lift and shift directly into your own applications. Actually, we just saw a message come through there. This shows a list of the ride times that came directly through from the MQTT client, and that will have updated the front end times just shown here. Okay, so I'm going to switch back away from this view for just a second, and I want to take you to the front end code that manages this. So I'll go back to my Cloud9 instance. Now this is very Vue.js specific, but it also applies to frameworks such as React and Angular. So these are component-based frameworks, and I've built a component called IoT. This is something I've used in many different projects I've built when I build proof of concept applications. So you'll see I use this IoT Core Vue.js component. And I'll show you very quickly what it does. The first thing it does is it uses this AWS IoT SDK, and this is a really useful library for your front-end web applications. What it does is when the application is first mounted, it forms this connection to Cognito to get the unauthenticated role for the application, and then further down, it forms a connection to the IoT device using that role from Cognito. And then the most important parts you care about are these three events that happen for your application. First, you connect to the MQTT client, and then when that subscribe event is fired, it then subscribes to the rides topic, which is the theme park rides topic we set up earlier. If there's an error, that gets logged out there, and then potentially you could take further action. But the most important event is this one here, the message event. This is fired every time a new message is received by the front-end client, and it tells you two important things. One is the topic, and the second is the payload. So the topic, you can filter in your own logic to see if this is a topic that you care about, to know what sort of processing that you need to carry out. And the payload in this case is the ride times, but it could potentially be any piece of information that you're tracking in your application. And so really, to bring in real-time processing into your front-end web app in Vue.js, you really just need a module like this with this sort of event handler to make all those changes. And because the front end is reactive, anytime you make changes to the data store, those are automatically updated in the front end. So I'll switch back now to these instructions. So after doing that push and making the change to the front-end console, where now we can see the front end showing real-time ride times, that completes this module. And so what we've done in this module is we've had this SNS topic that's already been completed and is already working. And we've created a Lambda function that listens to messages coming into that SNS topic. We pasted in the code that publishes those messages to DynamoDB and to the IoT topic. And then we set up our front end and to connect to the IoT topic to receive those updates. So what I'm going to do now is go into a bit more detail about this real-time connection that goes beyond these instructions. So you can follow these instructions later on if you haven't gone through all of these after the video. But for now, I want to show you some more information about how this connection really works. So when you have front-end and back-end applications, there are 5 main ways where you can pass data between the two. And it's important to think about all these different ways this works. So the first one you're probably most familiar with is a synchronous request and response loop using a service like API Gateway. We use this in the theme park when the application first starts up. This is the work we did yesterday. It makes a request to this API endpoint, and the front end is blocked. It waits synchronously to receive a response from the back end that contains the data payload for that request. This is the most common way people interact with backends, but it doesn't allow the back end to provide more information if things changes. It is basically a once-off request and response loop. The second method we have is using WebSockets with API Gateway. So API Gateway itself has a WebSocket method where if you want to send a request, you can leave a WebSocket open and the backend can continue to provide information back on that request. This is a good mechanism to use if you're not doing one-to-many type fan-out. So in other words, if your front end has a request that only really affects that one instance of that front end, then this is a good way to continue to hold a connection to the back end. The third method is using polling. Now this is not something new with AWS. Polling has been around for a very long time. And with this, what happens is your front end continuously pings a back end requesting to see if there's new information available. So in this case, you might set up a front end to ping your back end maybe once a minute to see if things have changed. Now, this is a really common mechanism, but tends to be very wasteful because many times you're pinging the back end and nothing has changed, so the back end isn't returning any new information. And if you're polling a back end once a minute, typically there'll be a lag between information becoming available and the front end knowing about it. In the fourth case, you have the option of webhooks. So webhooks are typically used in service-to-service configurations and not so much in front ends. So in this case, service A, when it calls service B, will provide an HTTP endpoint, which is a webhook, and service B calls that endpoint when something changes or the operation is finished. This tends to be something that is not so useful in web front ends, simply because it's hard to invoke that HTTP endpoint. And then the fifth method is what we've been using today, which is this IoT Core method. And this is real-time publish subscribe over MQTT. And it's something I think is incredibly powerful if you're a web developer and you're building these sorts of real-time front ends, because it's very easy to configure. And it also means that you have much richer eventing from the back end. If the back end wants to tell you something in real time, it can do using this mechanism. So if you look at publish subscribe in a bit more detail, this is what it looks like. The actual concept is not that complicated, but some of the implementation details take a little bit more thought. So in publish subscribe, subscribers can subscribe to a range of different topics that are going on, and publishers publish to those topics. So a topic can fan out to many subscribers. So you'll see in this case, topic C fans out to subscribers 3, 4, and 5. And the subscriber can also listen to many topics. So in this case, subscriber 3 listens to both topic B and topic C. Or a subscriber may only have one topic, or a topic may have only one subscriber. Any combination can work. So the mechanism for setting this up with IoT Core is actually very simple, but there are a couple of things worth thinking about for web applications. In web applications, it's common to have 3 different types of topic. One is an account level topic where you have one subscriber. These are for account pieces of information that affect only one user. For example, when you're in the AWS console and you have it open in 2 different windows and you log out from one window, you'll often notice that the other window says that you've been logged out. And that's using this kind of mechanism where there's an account level topic where a message is sent to it like you've been logged out, and it only affects that one single user. The second type of topic is a broadcast level topic that affects some number of users. So in the case of a chat room, for example, that could be the chat room itself. So all users of your chat application don't need to hear all messages, but all members of a chat room need to hear about messages in that one chat room. So that's when you would use a broadcast style topic. And then finally, there's the sort of topic where you want all your users to hear about things all the time. And these are really good for things like emergencies or broadcasts for outages and that kind of thing, where every single message will go to every single user on that topic. Now, the important thing about publish subscribe as a mechanism is it tends to be forward-looking, meaning that once the subscriber has connected to the SDK and they're subscribing to a topic, they're not going to receive historical messages. Things generally don't queue up or wait for people to connect. And that's one of the reasons why in this example application we use DynamoDB to store the last message for the list of ride times, because when the application first starts up, it may not yet have received a message from IoT saying that there's been a new ride time published. So DynamoDB holds the state of the most recent ride time. So IoT Core is this routing mechanism that we're using for this entire setup in the theme park application, and it's really easy to use in your own applications. So what it's doing is it's connecting publishers and subscribers. So as developers, all we have to think about is what we want to publish and to what topics, and then setting up some code in the front end to make it so that it can then listen to the right topics. Now, IoT Core is capable of publishing to a very large number of subscribers. So remember, with the theme park app, we have up to 50,000 users currently in the park. And in our backend, all we're doing is publishing once to IoT Core. So behind the scenes, what it's doing is it's managing that list of subscribers, and it's making sure that any of the messages that are coming in are fanning out to those 50,000 people who may be listening. So this is a very scalable system. It's also a fairly cost-effective way of messaging large numbers of people as well. If you look at the pricing for this service, this turns out to be a very effective way to reach lots of messages to lots of people. And remember, everything that we're interested in doing in our workshop today is serverless, because Having those servers means there's less infrastructure for us to manage. Now, many times when you're using this sort of mechanism with a WebSocket, often you need a serverless. The browser needs to have a server that it's forming a connection to. So obviously this is great for us because using IoT Core, it means that we don't need to have any servers in place for this to work. So whether you have one user or you have 50,000 users, the service in the background will scale up and down automatically. So the important things for your web app are that you need to decide on the topic structure, as we talked about, and then you need to set up the code for publishing, which is shown in blue on this slide on the left-hand side. So you'll find this in the theme park code. All you need to do is set use the publish method to send the topic and the payload. There's also a quality of service metric. 0 means the message will be published once to your front end. If you can set it also to 1, which means the front end has to acknowledge receipt of the message. So if you have messages where you need to make sure they're received by the front end, then you can set this to 1. Also on the subscribing application, in this case the web app, that's the code that we use shown in green on the right hand side. So this is the event that is fired on the front end, and in the event we're given the topic and the payload. It's then up to the application logic to deduce if the topic is of interest, in this case theme park rides, and then what we want to happen with the payload. So the critical thing is that a lot of stuff is being handled here by the SDK that's been bundled in. So with web apps and mobile apps, what you'll find is that connectivity can be very difficult to manage for many applications, because as mobile phones go in and out of areas of service, or as users open and close their laptops, they lose internet connectivity. So if you're writing this boilerplate code yourself, you have to handle these disconnects and reconnects. In the background, the AWS SDK does all of this for you, so you don't actually need to manage the reconnection on the front end. Now, I wanted to show you a little bit more about the template that you deployed yesterday, because we didn't have time to talk about it yesterday because there are a lot of different deployments. But you'll notice that yesterday we did 2 different types of backend deployment. The first one was the real-time YAML file, and the reason I've separated this out in this workshop is it's actually really useful for your own applications, because this one YAML file contains everything you need to be able to set up this real-time component. So what you'll see here is that IoT things are the key thing you have to set up first. And this is an AWS resource, just like any other resource. So we can define it in CloudFormation, and we can also set up permissioning using Cognito. So in this YAML file, you'll see that it sets up this IoT thing just in this section here. And again, you can set this up in the console if you prefer, but setting up in a SAM template is very easy with just 5 lines of YAML. This also defines a user pool client, and an identity pool, which are really the minimum things you need to do when you set up a Cognito. We're using just the vanilla settings here, but you can configure this to be fairly sophisticated depending on the security needs that you have with Cognito. And then a little bit further in that SAM template, you'll find that there is a Cognito role that's defined in SAM. There's 2 of them actually. One is an authorized role, and one is an unauthorized role. So it's really important that we've got two capabilities here. The first is the authorized role is for people, users of your application, who've authorized with a service like Auth0 or Cognito, and they've got a JOT token available, and they can authenticate with Cognito. Once they've authenticated correctly, this is how you can make sure they only receive messages that are for authenticated users. Then the other type of role is the unauthenticated role. So these are for users where they haven't authenticated in, but you want to still be able to send them messages. So those 2 roles are defined here. So for example, if you were building a banking application where users could get into their accounts and see their balances, you might use an authenticated role to publish information about their account, such as when payments were processed. And you might use an unauthenticated role to tell all users about things about your company, such as when store hours change, or if there's been some sort of change to your business. So using those 2 things, that's how you can essentially secure the IoT topics within your real-time web application. So what I'll do now is I'll take a quick break to look to see if we have any questions, and I'll come back in just a couple of minutes. Okay, so one question here is about this DynamoDB configuration, and it's a good question. So right now we've set this up so the SNS topic, when it receives an event, triggers this Lambda function, which then saves the message into DynamoDB, and then also publishes it to IoT. So this is to solve two different problems. We publish to IoT to help any real-time connections that are listening, so anybody who's actively using the application. But then we also use DynamoDB to remember the last message pushed out. And this is so that anybody who's just started the application can get the state of the last message, a kind of state of the world message. And this, if we didn't have that, what would happen is that when people first start the application, they wouldn't see any ride times at all in the application until the latest message was pushed through to IoT. So it's really to help improve the user experience. But otherwise, there's nothing else consuming the data in the DynamoDB table. So how is IoT different from SNS? That's a great question too. So IoT is really, the service does a couple of different things. So first is it can reach out to real world devices that are out there. And so you'll see my team publishes lots of blog posts about how you can build IoT applications with serverless. If you look at Mohib Zara's blog posts, he writes lots of those, and they all use this IoT Core service. But IoT can also involve anything really that can listen to a topic. So in our case, our web apps themselves, the device, are IoT consumers. Now, SNS is a different kind of service because it has different types of endpoints. SNS can publish to email addresses or to SMS messages, and it can also fan out to an enormous number of different listeners. And so really, SNS is more of an infrastructural piece that you would use on the back end, whereas IoT is something that you would use once you want to publish or receive messages from devices and consumers in the real world. Where can I find more information about how to programmatically publish a message to an SNS topic? Well, actually, I can show you that just very quickly in the code. If I just go back to what we deployed in Cloud9, yesterday in the backend directory, we did module 1, so I'll just go to there. There is an application called the ride controller, and that's a simulator that I built that helps produce the ride times to publish them out. So this was deployed for us automatically yesterday. If you go into the controller directory, you'll see an application called app.js. And in here, this is a little piece of Node.js that publishes the messages to SNS. You'll see this requires an SNS.js file from here. And in this library, this contains the code you need. So it's really just one line to publish to SNS. So in this case, it publishes to, there's the message topic there, and the topic ARN is handed in by the SAM template. But that's all you need really to publish to SNS programmatically using a Lambda function. So the SNS topic, I realize there's a little bit of magic here with how the ride times are being generated. That's all coming from this application, this ride times controller that you deployed yesterday. It's a behind-the-scenes application that in the real life you would think about as being another service that's providing data that you want to ingest. But if you're interested in seeing how that works, take a look at the ride controller folder. This contains a SAM template that publishes out the Lambda function that makes this work. But essentially, its main job is to give you some sort of simulated parameters for wait times and outages within rides within the theme park. So one question about using this in other regions. So right now, this workshop, I've tested it in 5 different regions, and I'm slowly testing more regions for us to roll out to. So hopefully that list of regions will get larger fairly quickly. But for now, if you can use one of the list of 5 regions where I've tested all the code, that way I can ensure that you have a good user experience and there aren't any issues that I've not discovered. But hopefully I get some more regions fairly soon. Okay, on the SNS topic, just to mention this once more, with the SNS topic, so we're pushing messages to SNS from the ride controller application that was published yesterday as part of our deployment there. So that just runs once per minute, and it creates some ride times that are published to the SNS topic. Today we created the Lambda function that consumes those messages from the SNS topic, and so SNS is really acting as a bridge between those two different services. One question about AWS Amplify and being charged. So AWS Amplify has a fairly generous free tier allowance. So you can find that in the pricing tab of the AWS documentation that we can paste a link into the Q&A. And for projects that are small scale, you'll find typically you should be covered within free tier allowance. And so you shouldn't be charged by Amplify for anything by running this workshop. So one question about using the persistent message stored in DynamoDB from the work that we did today. So that ride time, we post the most recent ride time to the DynamoDB table. And the reason for that is that if you then have users who are starting up the front end, the first thing the front end does is call that API gateway endpoint that we configured yesterday. And that returns the most recent ride time list from that DynamoDB table. So that means the application can immediately show some wait times in the application and not wait for the next published message from IoT Core. It's not something you have to do, but generally it helps provide a better experience for your users, because with real-time applications, otherwise they have to wait for the next message when it's published, and there could be some period of time before that becomes available. Are SNS and IoT Core chargeable? Yes, both are services that you would pay for. Both are also, you can find the pricing for those within the pricing tabs on each service. But generally speaking, these are both relatively inexpensive. And so for IoT Core, for publishing to large numbers of clients, it's actually a fairly cost-effective way of pushing out large numbers of messages. So I want to ask why I'm using try catch. So in these functions, I'm using try catch as really a minimum type of error handling. I'd recommend obviously you write more robust error handlers for your production applications. Now with this theme park workshop, this is a public GitHub repo. So if you ever want to make suggestions for code changes, you think something could be better, absolutely please submit a pull request. And it could be something we can incorporate into the workshop to make it better for future attendees. Okay, so just to recap very quickly today. So today we implemented real-time messaging for our web application. Yesterday we just had a skeleton web application that could receive information from an API gateway endpoint, but it had no way of continuously receiving updates for things like ride times for our theme park. So today what we did is we built this Lambda function that can listen to incoming ride times from an SNS topic, and it published those ride times to an IoT Core topic. And then we connected up the front end so it too could then listen to these messages coming in on those topics. Now one of the things that's really interesting in the code is that Vue.js can then automatically receive those messages in through an IoT component and update its internal stores so the UI is kept up to date with those messages. So then we also talked about the pub sub pattern, the publish subscribe pattern, and how you can use this with IoT Core within your serverless web applications. So that's it for today, but to continue on tomorrow, the same day, same time, same time, same place, please don't delete any of the resources that you've been deploying. Please continue to get through modules 0, 1, and 2, and then tomorrow we'll be continuing with module 3, and we'll pick up off there. If you have any questions at all between now and then, please feel free to reach out to me. You can reach to me at email on jbezic@amazon.com or via Twitter at this handle shown on the screen. Thanks very much for your time today. Thanks for attending. I'd really appreciate it, and I'll see you tomorrow.